This is the geometry quadrilateral unit review. Alright, so starting this, we look at number 1. Okay, it states that prove that the parallelogram for x is 7 and y is, prove that it is a parallelogram. Okay, I'm sorry. Alright, so a couple things that we know. If it's going to be a parallelogram, we're going to make sure that these actually come out to what the answer is. So in a parallelogram, we know that these two right here are going to be equal to each other. So that's one of the properties of being a parallelogram, is opposite angles are congruent. So these two together, since I have y's and y's, and this is x, I only could do the y's together. So it's going to be 9y plus 1 equals 10y minus 13 minus 1 minus 1. So it's 9y equals 10y minus 14 minus 10y. Negative y is negative 14. And then divide by negative 1, where I get y is positive 14. So I was able to prove this piece right here. So now the next thing I'm going to do is I'm going to prove that this one's going to be 7. I know that these two together, those two together, have to add up to 180 degrees. What I'm going to do is I'm going to take this and I'm going to plug in. I know the value of y. I need to figure out the value of this angle right here. 10 times 14, because that's my y value, minus 13. 127. So this angle right here is 127 degrees. And like I said, both these together have to add up to 180. So my math is going to look like this. It's going to be 7x plus 4 plus 127, because I'm not going to plug this in because I don't want two different variables. Both these angles together have to add up to 180. So 7x plus 131 equals 180 minus 131. So let's see, 180 minus 131 gives me 49. So 7x is 49. Divide both sides by 7. X is 7. So by doing that, I was able to prove x is 7 and y is 14. Here, I'll back it up for you right there. Number 2 says, tell whether the parallelogram is a rectangle, rhombus, or square. Justify your answers. So, a couple things I need to figure out. First, I'm going to figure out the slopes. So if I had my checklist, I would go down, hey, 4 sides, that means it's going to be a quadrilateral. So I need to go down and look at that family tree that I had. So I need to know these right here are going to be parallel, so that would make it, okay, a parallelogram. So first thing, I'm going to do the slope. So for slopes, so I'm going to do all the slopes. So it's going to be for FG, the slope is, so it's rise, so it's going to be 1, 2, 3 over 1. Okay, and for the next one, so the opposite side should be parallel to it, which should be ED. The line segments right there. ED, 1, 2, 3 over 1. So these two are going to be parallel. The other sides are going to be for GD. GD, it's going to be, if you notice, it's going down now. So it's down, so it's going to be a negative down 2 over 1, 2, 3, 4, 5, 6. Down 2 over 6, which reduces to negative 1/3. Now for FE, right here. So now from here, it's going down again, because I read from left to right, down 1, 2. So that's going to be negative. So it's negative 2 over 1, 2, 3, 4, 5, 6 over 6, which reduces to negative 1/3. So a couple things I need to point out real quick. These and these, so those two are parallel to each other, those two are parallel to each other, but they are opposite. So they're opposite and they're reciprocal. So this is 3 over 1 and this is 1 over 3. This is positive, this is negative. So it's opposite reciprocal. So that means that those are perpendicular. So it means that each one of these corners is a right angle. So now going through my checklist right here, so right now it could be a rectangle, it could be a square, but a rhombus right here, it doesn't have right angles. So I could cross that off my list right there. Now the next thing I'm going to do is I'm going to check the distances. So in a square, all 4 sides are the same. And in a rectangle, only the opposites are the same. So the only ones I need to check now is this length here and this length here. So if I check these lengths and I'm verifying it, you guys are looking at this and say, oh, it just looks like it. But we need to verify this. And to get all your points for these questions, you have to be able to show what you have here. So we're going to find distance. So distance. So my distance for FG, so it's going to be equal to the square root of, now if you were one of my students, then you know that it's going to be delta x. So how far is it in between here and here? So I'm making a right triangle right here. So my x is going to be 1 squared plus, and my y's are 1, 2, 3 squared. So that gives me, so it's 9 plus 1, so square root of 10, which is about 3 point something. .16, which is 3.2. So that's this piece right here. Now I need to do the same thing. I'm going to do the same thing for GD. So for GD, when I find the distance there, that's going to tell me if these two, so if the distance of this is the same as distance of this, that means that all of them are going to be the same. So let's go through and find out this one. So GD is going to be the square root of, so now let's see. I'm going to make a little right triangle out of this. So my x's, so if this is a right triangle, my x's, so I have 1, 2, 3, 4, 5, 6, plus my y's, which are 1, 2. So that's going to be 36 plus 4, square root of 40, which gives me about, that's going to be 6.4? I don't know. Maybe I should do the math instead of guessing. 6.3. So since these ones right here are not the same, so they're not the same, so that means that this one here is not the same as this one here, so that means that it can't be a square, because in a square all the sides are the same. So therefore my answer has to be a rectangle. This one is a rectangle. Now for number 3, let me zoom in. So for number 3 it says use the figure to answer the questions below. So the first thing, mark the box next to all of the shapes shown in the figure above. All the shapes, plural. So I have the big thing, which is a parallelogram. It classifies as a parallelogram. It classifies as a right here, rectangle. So a square, all sides are the same. So I can't actually verify this yet, but I will here in a minute. So square, all sides are the same. A rhombus has all sides are the same, but there's no right angles in the corners. And a trapezoid means that only the top and bottom are parallel, and it's not possible to have more than 2 right angles in it. So that means that I could automatically cross out this, and I can cross out this because of the right angles. But square, I have to be able to prove that all the sides are going to be different. So we can't actually just go by the shape, because I don't know if you notice this, but I'm not very good at drawing shapes. You'll come to find out that when we go try and do the circle here in a little bit. So solve for x. Now if I'm solving for x, in this one right here, so even if it is a rectangle, so in a rectangle we know that the diagonals are going to be congruent. So right here, so now I know that this piece here is going to be congruent to this piece right here. These are going to be congruent, so that would make this an isosceles triangle. So with what I have here, I could state that I have, so you see this, 6x plus 5 is equal to 8x minus 17. So subtract 5. 6x is equal to 8x minus 20. Wow, I'm horrible at this. 22 minus 8x from both sides. So that gives me a negative 2. X is equal to negative 22. Divide by negative 2. X is 11. So now I solve for x. Next question says find the length of the quadrilaterals of the shorter sides. So let's see which ones are going to be shorter. So if x is 11, with my calculator, I'll even show you. So when x is 11, so 7 times 11, so that means that this one is going to be 77. 13 times 11, that's going to be 143. So now the measurement of the quadrilateral's shorter sides, so smaller numbers, is going to be 77, whatever units those are. Now let's take a look at 4. Complete the steps of the proof using the below diagram. So now, starting off right here in the very first thing, I'm going to start off with what is given. I'm always must start off with my given. So I'm going to back this up a little bit so we could see this. So my first statement is going to be that it is given, because that's right here. Now, that says that it is a parallelogram. So now, with being a parallelogram, there's all kinds of things that I automatically know. So I'm going to have to come back to that piece here in a second. So it says AEC. So the next one, AEC is congruent to BED. So now AEC, so it's going to be this piece right here, is congruent to this piece right here. And I know everyone right now in their head should be saying the words, hey, given this statement, those two right there, opposite sides, those are vertical angles. So reason 2, those are my vertical angles. Now, the next thing I'm going to have says AC is congruent to BD. So let's go ahead and mark that. AC is congruent to BD. And it says that AC is parallel to BD. So they're also parallel, so I'm going to throw in those arrows to say that they are parallel also. And that would be, for reason 3, that's definition of parallelogram. So I have definition of parallelogram for that reason, because when I stated it's a parallelogram in the first place, a lot of things automatically will happen because of that definition. Now, the next thing is going to be that I have CAD, CAD, so that's going to be this angle right here. I'm going to put the double markings in there. So this angle right here. So CAD is congruent to angle BDA, BDA. So it's this angle right here. And these two are going to be congruent because I needed to state that they're parallel to each other. So that's parallel. That's parallel right there. Okay, so now if they're parallel, that means that this line right here would be the... Alright, so if you automatically get this vocabulary word, give yourself candy for it, because I'm not there to do it. Okay, this is going to be your transversal. And that means that these, after I state they're parallel, so my reason for is going to be that they are alternate interior angles. So there's reason 4, alternate interior angles. Now, for the next thing I have, so we're proving that the triangle ACE is going to be congruent to triangle DEB. So it's this triangle here and this triangle right here. So this one right here is going to be enough information. So this is an angle, that's a side, angle, angle, side. So now my reason for 5 is that it's going to be angle, angle, side as my final reason for that. For number 5, it says inscribe a regular hexagon inside the circle O. Now, again, a lot of things don't come out like they should. And so I apologize. I already know that it's not a perfect circle, so please no crying. So I'm going to zoom in for this so you guys can see. Now, I made sure there's some paper underneath there so I don't stab into my desk. I would be very upset. So what I'm going to do is, so first thing to inscribe this, I stab the center, measure out to the edge, so there's the edge of the circle there. And now that I did that, so I'm going to pick any point right here. So I'm going to pick a point on the edge, and I'm going to draw an arc. I'm going to move to the next one, draw the next arc. So I'm going to keep going around the circle like this. There we go. So I walked all the way around. So I made it all the way back to the beginning. So now the next thing I'm going to do is I'm going to use a straight edge, and I'm going to go through and I'm going to connect all of those together. So let's go ahead and connect these. So I have to use a straight edge because of all the things I have at my house. I have a compass, but no rulers. There we go. Yay! Regular hexagon. Now, number 6 said inscribe a square in the circle. So now, I know everyone paid attention when we did this the first time, so I'm going to try and go kind of quick on this. First thing I'm going to do, I'm going to draw a diameter. And diameter could be any direction as long as it goes through the center and it connects both sides of the circle. So that means that I have a point here and I have a point here. Now the next thing I'm going to do is I'm going to create a perpendicular bisector. So that means that I'm going to stab here at the edge. I'm going to open it up more than halfway. So and don't forget, you have to have these arcs, otherwise you're not going to get credit for this. So if you go ahead and try and draw this without, which I was watching some people try, it didn't come out very well, you're not going to get the full points. So I have my perpendicular bisector arcs right here. So now the next thing I do is, here's my point, here's this point. So I'm going to draw a line through those 2 points connecting both sides of the circle. So I'm connecting both sides of the circle from there. Now the next thing I do is these are my endpoints of my square. So I'm going to connect the edges right there. There we go. So I have my square. Might look slightly off because the circle that I made and I printed out, it wasn't exactly perfect, but the square is done. I have all my arcs to prove it, so I showed all my work to go along with it, and that is going to get you your full points. Now for number 7, it says coordinates of the vertices quadrilateral, okay, are there. So I'm going to go through and I'm going to put my points. That red pen was dying on me, so I don't want to use that one because it was bleeding everywhere. So let's take a look. So let's put my points. So A is at 1, 5. So 1, 2, 3, 4, 5. That's going to be my A. B is at 4, 4. 4, 4. C is at negative 4, 0. Negative 4, 0. And D is at negative 3. 3. 1, 2, 3. Right there. And that is going to be my D value. Connect my points. Yeah. There we go. Got that one. There we go. So I have my points. Just by looking at it, I automatically say, that's pretty sure it's not a square. So I can start with that. It has 4 sides, so it makes it quadrilateral. Now I'm going to back it up right here. So now it says, how long is each side of the quadrilateral? So how long is a question asking for distance? So in distance, okay, not everyone that watches these videos are my students, so I'm going to give you a distance formula. So distance is equal to the square root of delta x squared plus delta y squared. This one right here, delta means it's the difference, it's a change, so it's how far they're apart, how far the y's apart. And using this method, it's accounting, so we could actually just look. You have to understand a number line. So we're going to do all four sides. So let's go with, let's start with AB. So the distance is, so how far are my x's apart? So from A to B, from 1 to 4, it's 3 apart. I could even count it. From 1 to 4, it's 3 apart. 1, 2, 3. 3 squared. Plus, now the y values comes next. So how far is 5 away from 4? It's 1 apart, so I could even count on the y values. It's going to be 1. 1 squared. So that's going to be 9. That's going to give me square root of 10, which gives me approximately 3.2. So do the next one, which is, let's go BC. Now, my change in my x's, so from B to C. So how far is 4 away from negative 4? That's going to be 8. I could actually count it. 1, 2, 3, 4, 5, 6, 7, 8 squared, plus my change in y's. How far is 4 away from 0? That's going to be 4 spaces away. 4 squared. So it's going to be 64 plus 16. Gotta do the math. 64 plus 80. So I get square root of 80, which is going to give me about 8.9. So I have that one. So let's do the next one, which is going to be CB. Oh, I'm sorry, CD. So CD. So from C to D. So from, I'm sorry if you can't see this from the screen. Let's see if I can move it a little bit. There we go. So for CD, so how far is negative 4 away from negative 3? That's going to be 1 space away. Plus, so I could even count them apart. From 0 to 3 is 3 spaces apart. So that's going to be 9 square root of 10. There we go. So square root of 10, I already had that one earlier, 3.2. Now the last one is going to be AD. So AD. So for AD, go back up here, from 1 to negative 3, that's going to be 4 spaces apart. So I could count it if I need to. 1, 2, 3, 4. The x is going to be 4 spaces apart, plus the y's, which is going to be between 5 and 3, which is 2. So let me see, 16 plus 4 is 20, square root of 20. So that should be like 4.6. 4.5. So 4.5. So here's the measurements of all my sides. Sorry. Here's the measurements of all the sides. So this right here, how long is each side? Show your work. I'm showing all the work for this. So that's going to get you your full points. Now for part B, it said, what are the slopes of each side of the quadrilateral? Show your work. So now I have to find the slope. So I'm going to underline slope right there because that's telling me what I'm going to do. All right. So now with the slopes, I'm going to write out the slope formula. y2 minus y1 over x2 minus x1. So this is what they're asking for by show your work. So we want to see this. So you can't just use the graph and count it. So we want to see using the slope formula. So we're going to go through all of them. So let's go AB again. So for AB, so y, so between these two, so y from the second point is going to be 4 minus 5 over 4 minus 1, which gives me negative 1 over 3. Negative 1 over 3. Next one's going to be BC. So from B to C, so that's going to be 0 minus 4 over negative 4 minus 4. So it's negative 4 over, that's going to give me negative 8, which comes out to be 1/2. Okay, where am I at for the next one? So the next one should be CD. So for CD, so it's going to be 3 minus 0 over negative 3 minus negative 4. So it's going to give me 3 over, that's going to give me a positive 1. So those change to a plus, so that's positive 1. Now, the next one, that was CD. And the next one's going to be, let's see, last one is AD. Sorry. So AD is going to be, let's see, from right here, so it's going to be 3 minus 5 over negative 3 minus 1. 3 minus 5, negative 3 minus 1. Okay, so I should have negative 2 over negative 4, which comes out to be 1/2. So that reduces to a positive 1/2. So I have all my work, I showed my formulas, I showed all my steps. That gives me a full points. Now, I need to use this information that I have here to be able to find out what I know. So I know that AD and BC, they have the same slope. So if they have the same slope, that means that they are parallel. So this one is parallel to that one. So those are parallel. So that means now I have one pair of parallel sides. Now, right here, these are not parallel. So since they're not parallel, that means it cannot be a quadrilateral, or I'm sorry, it cannot be a rectangle, and it cannot be a parallelogram because of those things right there. But because if I look over on my distances for AB and CD, so AB is 3.2, CD is 3.2, so that means that this piece is congruent to this piece right here. So they're parallel, and these two sides are